Okay, we're going to talk about absolute value, equations, and inequalities. And so the first thing we're going to notice in these three equations is that, well, first of all, they're equations because they all have an equal sign. The second thing we're going to notice is that on the right-hand side, two of them have something more than just the absolute value. This one has a -3 and this one has a 5 on the outside. So we're going to, in order to get the absolute value alone for example 2 and 3, we're going to have to get rid of those two things. Okay, so those are just some things to look out for. Okay, so on the first one though, the absolute value is alone, so we're saying the absolute value of x minus 4 is equal to 10. Well, 10 is a positive number, so that means that x minus 4 could have been a 10, or x minus 4 could have been the -10. And we're going to go ahead and solve that. Add 4, x equals 14. Add 4, x equals -6. So our answers will be -6 and 14. So on the second one, we have that -3 is there, and or else it would look exactly like the first example. So the first example already had the absolute value completely alone. The second example has the -3 there, and we're like, oh, well, we would really appreciate if that wasn't there, so we're going to go ahead and add 3 to both sides. So we get x minus 4 is equal to 13. So the absolute value of x minus 4 is equal to 13. Now we're kind of back to what example 1 was. So we're just going to say that x minus 4 could have been a 13, or x minus 4 could have been a -13. And we'll solve those by adding 4. So x was 17. X was -9. So we have -9 and we have 17. Again, we just have 2 points, two values that would make our inequality or our equality, our equation true. Okay, the next one we have, we're going to look at, here has the 5 on the outside, so it's 5 times the absolute value. Never distribute, oops, let's erase that. Oh, it's not letting me write up there. Never distribute into an absolute value. So you would never have taken that 5 all the way in because you're not going to distribute into an absolute value, so you'd have to divide both sides by 5 in order to get the absolute value alone. The 5s will make a 1, and then you're back to the absolute value of x minus 4 is equal to 2. So now you're back to the absolute value equal to a positive number. So we would have x minus 4 is equal, could have been a 2, or x minus 4 could have been a -2 because both of those things are 2 units away from 0. And then we solve. So when we add 4 to both sides, we get x equals 6. Add 4 to both sides, and we get a 2. So we'll end up with 2 and 6. As our two values. Okay, when we move on to our next thing, we're going to be looking at inequalities, and you can see that each one of these has an inequality. You also see that, like the other ones, the absolute values aren't exactly alone, so we want to make sure we're keeping track of that. When we have inequalities, we're not just talking about 2 points, we could be talking about several points, so we want to be just more mindful of that. But we're still going to get the absolute value alone first. So we're going to add 5 to both sides. Absolute value of 2x plus 2 is less than 20. Now, when we're talking and we're saying that the absolute value is going to be less than 20, if I tell you the distance is less than 20 away from 0, that means it's getting closer and closer to 0. So that means we're going to be using an and to describe it because it's getting between two values. So we're going to be overlapping. It has to have two conditions held. So the first condition is 2x plus 2 would be less than 20. And the second condition is that the 2x plus 2 would be greater than the negative 20, because when you take and you do the opposite, you would flip the inequality. Okay, then we go ahead and solve. Subtract 2, 2x, and then 18. We've already kind of talked about this a little bit, but we're still going over it. So we get the x is less than 9, and the important word, we subtract 2, 2x is greater than negative 22, x is greater than negative 11. So our boundaries are negative 11 and 9, and they're open because there's no equal sign. And when I say what we're going to get for the first one, we're going to have x is less than 9, so that means that everything less than 9 would work. And for the second one, we're going to say everything greater than negative 11, so we're going to go greater than, and you can see where they overlap. They overlap right in between here. So the area that they overlap is right there, and that's where all the x values that would make it true. So we're going to have open interval negative 11 because we didn't include the negative 11, and it ends at 9, and that's also open because we didn't include the 9. So that's the interval notation for that. So we kind of went into the next space, but we'll be very careful. So on this one, our absolute value is alone. For example 5, our absolute value is alone. And it's saying that the absolute value is greater than 9. Well, what kind of numbers are greater than 9? What kind of numbers are greater than 9? Well, I'm sorry, greater than negative 9. Are positive numbers greater than 9? Negative 9? Yes. All positive numbers are greater than negative numbers. So right here, any x value would work here because all of your outputs would be positive here. So no matter what x you put in there, we would get a number greater than negative 9. So in this case, all real numbers would work. But let's say we didn't realize that. Let's say we did not realize that. So let's go ahead and see what's going on here. We would set up our two cases, but when we say greater than, we're talking about getting further away from the center. So we have 2x plus 1 is greater than or equal to a negative 9, or 2x plus 1 is less than or equal to 9. And we solve these. 2x is greater than or equal to negative 10. X is greater than or equal to negative 5, or 2x is less than or equal to 8, so x is less than or equal to 4. Now, we'll look at these two things. We have a negative 5 and we have a 4. So for the first one, we have all the x's are greater than negative 5, and we are including the negative 5, so we fill it in. And then for the other one, we are including the 4, but for the other one, we are going to say all the x's less than. Now this looks just like example 4, except for instead of having an and, we have a or. Now or means we're going to take everything, not just the overlap. So if we look at our number line, we have everything over here and everything over here. So we are going to take the whole entire number line, and what our answer will be is all real numbers. Now, in interval notation, and this is an arrow, in interval notation, this would look like going from negative infinity, from the smallest infinity to the largest infinity, but we never actually get to infinity, so it's open at the ends. So that would be what our interval notation looks like. So again, because it's an OR, we're going to take all of the orange and all of the green, which means we take the whole entire set of real numbers. Okay, now I kind of used part of example 6 space, but it's okay, and you'll see why. Because in order to do this problem, we just have to take care of this little -5 first. So when we divide by -5 on both sides, when we divide by negative on an inequality, we have to change the inequality. We have to flip the inequality. So because we're going to flip the inequality, this will become absolute value of x plus 2 is greater than or equal to a -5. Well, what happened before when we had the absolute value of something greater than or equal to a negative number? What happened? Let's see. That was over here. Over here is where we had that. When we had the absolute value greater than a negative number, we got all real numbers. And so once we see that there's always going to be, all of the x's are going to be able to make the absolute value greater than a negative number, we are going to be able to write all real numbers. We don't have to go through all that work. We don't have to go through all that work, and we just have to shade all of the numbers on the number line. And we remember that we're going to go from negative infinity to positive infinity with open interval. Okay. The last one that we're going to do is we're going to look at basically the answers and come up with our absolute value. So our goal is going to be an absolute value on this one. And our goal for this one is also going to be an absolute value with a variable. So let's look and see what this graph would look like. If we were looking at this graph, it would have been from 40 to 50. It would have been open at the end. And so if we were looking at the middle of this, the midpoint right here, we can see that all these x values that are in here are getting closer to the center. They're not getting further away, they're getting closer to the center. So we're going to say that this is going to be less than our distance. So first we want to know what that midpoint is. So we're going to say all of our x's, let's find the midpoint like we would in geometry. We're going to take the endpoints, add them up, and divide by 2. When we do that, we get 45. So that is our center. And the distance between 45 and either one of the endpoints is 5 units. And so all of our green points are less than 5 units away from 45. That's the story that's being told. So there's our inequality for that one. Okay, so when we look at this one, we're going to pretend like this is filled in because I wanted this to be filled in. So here's our x's, and they're not, you can see how in the first one, this guy over here, it was between 2 points. This one over here, it's going out. It's going away from the midpoint. So you can see, and I'm going to make it a little darker, how it's going out away from a midpoint. It's going out away from a midpoint. Okay, so first we need the midpoint. So let's go find the midpoint. We're going to have the 11 plus 7 over 2. So there's your 9. So x minus 9. And then we're going away, so that means our distance is getting further away from our 9. And how far is it from our 9 to our to our endpoints, and that's 2 units.